Hello students. Yes, sir. Welcome back to the session of current electricity. In this session, we'll discuss few miscellaneous questions. Okay, right. Few miscellaneous questions. So one of the question is, yeah. Let me discuss. Kind of is in CBSE pattern. In CBSE exam pattern, if you observe, some case study questions also will be asked. One of such questions, we'll see what kind of questions will be asked and how to answer case study based questions. So I'll give you one simple example. Like this kind of questions will come. Okay. So let us consider one simple example here. And so let us say this is the case study given. The case study based on electric circuit analysis is an electric circuit consists of a 6-volt battery and electric circuit consists of a 6-volt battery connected to connected to three resistors R1, R2 and R3. Let us give some names as R1, R2, R3. Simply we can say connected to three resistors of resistances, of resistances 2 ohm, 3 ohm and 4 ohm. 2 ohm, comma, 3 ohm and 4 ohm respectively. Fine. So this is a simple case. Okay. Then the questions will be asked based on this simple case like this. Then calculate. Sometimes these questions under the case study will be given as objective questions also. Okay, here the questions I'm giving the questions like this. To calculate, or you can say, then the total resistance of the circuit is. You can take like this. Then the first one is, then the total resistance of the circuit is. So options also may be given in examination point of view, but I'm not giving the options. I'm asking you guys to practice by yourself. I will give you this. Okay, these are simple questions. And let me give you all questions first. Two, the total current I flowing through the circuit is. The total current I flowing through the circuit is. Total current I flowing through the circuit is. And a third part of this case study question is the voltage drop across each resistor. The voltage drop across each resistor is. And the fourth question from based on this is The power dissipated by each resistor, the power dissipated, by each resistor is, and also the power supplied by the battery is. If the case study is asking for 5 marks, you may get 5 questions like this. The power supplied by the power supplied by the battery, by the battery is. Okay. Sometimes this case study questions will be asked for 4 marks also. In such case, if the case study question is asked for 4 marks only, in such case, 4 sub questions only will be asked under this case study. If it is asked for 5 marks, sometimes case study questions will be asked for 5 marks also. In such case, you may get 5 sub questions. Okay. Right. Okay, guys. Actually, yeah, here one of the questions, one of the point here is not clear in the question is the electric circuit consists of a 6-volt battery connected to 3 resistors of resistances. This respectively is mentioned. Whether they are connected in series or parallel is not mentioned clearly. Yeah, yes, man. One of you guys have pointed out that was this Muhammad Faris in series or parallel. Yeah, very good point, man. Actually, here we have to just. I missed this to mention here. They are connected in series. Okay, here they are connected in series. Three resistances, 2 ohm, 3 ohm, 4 ohm, respectively, are are connected in series. They are connected in series. Note down that properly, guys. Note down this properly. Yeah. Right. First, let us see one by one. First part, the total distance of the circuit is nothing is there to calculate, right? So, but let us try to uh, depict this data in circuit form, pictorial form or circuit form. So, what is given here? An electric circuit consists of 6-volt battery connected to 3 resistors, okay, in series. So, try to draw a circuit diagram for the first one. Depict the given data in circuit form like this. First resistor, second resistor, third resistor, they are connected in series to a battery of potential difference 6 volts, right? 6 volts only, right? And resistors having, let us say this is R1, R2, R3. R1 is, what is R1? R1, R2, R3 are 2, 3, 4 ohms respectively. 2 ohm, R2 is 3 ohm, R3 is 4 ohm respectively. Then the first part is, what is the total resistance? Obviously, as the resistors are in series, the current I drawn from the battery is flowing through all the resistors. The same current is flowing, so the resistors are said to be in series. So R effective or total resistance of the circuit is as they are in series combination, it is nothing but R1 plus R2 plus R3. So it is equal to 2 plus 3 plus 4, right? 5 plus 4, 9 ohm is the answer for first part. Right, next, what is the second part of the question? Let us see the question here once again. The total current I flowing through the circuit is, yes, the total current I, total current I in the circuit, in the circuit is given by, as current I from Ohm's law, I is equal to V by R. Here you have to take E effective by R effective, as only one cell is there in the circuit. Look at the circuit once again. So E effective is nothing but potential difference of the cell or EMF of the cell. It is nothing but 6 volt. R effective already have calculated, that is 9 volt. Sorry, 9 ohm. So 6 by 9 is equal to 3 2's 3 3's is equal to 2 by 3 ohm. Sorry, 2 by 3 ampere. Or you have to just simplify this further. Okay. So 2 by 3 ampere, or in decimals if you want. So you can say it is 0.36 is 18. So 0.6 ampere. 0.6 ampere. Okay, 666 or 67 ampere. And so you guys can try by yourself. Meanwhile, this is second part. This first part, second part, third part. What is that? The voltage drop across each resistor. Try to draw this circuit once again so that you will get clearly. The voltage drop. The voltage drop across each resistor. Across each resistor is. So redraw the circuit once again, guys. R1, R2, R3. It is connected to the battery of potential difference. Sorry, of potential difference 6 volts. It's 2 ohm, 3 ohm, 4 ohm. So let us say this potential, if we say this is V, we will drop across this as a V1, V2, V3. So sum of these potentials should be equal to V. That's what you have to just keep in mind. So but as from Ohm's law, if you say as current I is drawing here, same I is flowing through each resistor. Potential difference across each resistor is given by through the first resistor. Potential difference across first resistor R1. First resistor R1 or across resistor R1. First resistor is equal to from Ohm's law, V is equal to IR. So it is the same current is flowing through each resistor. I is common, so you can say I is same. So I into resistance is, if you have to say it as R1. So I R1 is equal to, what is I? Already have calculated. I in the circuit is what? 0.6 ohm or 2 by 3 amp. Sorry, 0.6 ampere, 2 by 3 ampere. So I is what? 2 by 3 ampere into R1. R1 is what? 2 ohm. So it is equal to 4 by 3 potential difference volt. 4 by 3 volt, or 4 by 3 is what? 1 point, yeah, 3. So 1 remains, so we have, if you mention put a decimal and it becomes 10, so it is 3 is 1.3 volt. 4 by 3 volt or 1.3 volt is what you call the potential difference across the first resistor. Next, potential difference across second resistor. Potential difference PD. PD means potential difference. Potential difference across second resistor is equal to IR2 is equal to, what is I? Same, 2 by 3 ampere. R2 is 3. So here 3 gets cancelled. So it is equal to 2 volt. Potential difference. Volt, 2 volt. Then next, potential difference across. Third one is potential PD. Potential difference across third resistor is equal to I R3. So I is what? 2 by 3 only, into R3 is 4. So it is equal to 8 by 3 volt. So it is equal to, so how many times it goes? 3 ones, 3 to 6, right? 3 to 6, 2 remains. So, 6 times it goes, right? Or you can write, yeah, yeah. So 666 will get, so you can write it as 2.67 or 2.7 volt. Okay, approximately, right? So this is how you have to calculate the potential difference across each resistor in series combination of 3 resistors, guys. I hope it is clear for you. Next, fourth part of the question. What is that? The power dissipated by each resistor is, power dissipated by each resistor. So while calculating power dissipated, you have to be very careful. Already we have discussed this kind of questions. Next, what is this? Fourth part of the question. Power dissipated across each resistor is. So in series combination, again you can redraw this for understanding purpose here for every question. Otherwise, just you can go up and observe and come, no problem. Okay, right. So 2 ohm, 3 ohm, 4 ohm, 2 ohm, 3 ohm, 4 ohm, and the potential difference of the cell. I have to draw the circuits properly, guys. So 6 volts, and a current I is drawn here. Same current I is flowing through each resistor. Now, as current I is flowing here, power dissipated as in series combination. What is constant? Current is constant. So power dissipated across first resistor, if you say this is R1, R2, R3. So power dissipated across first resistor can be taken as P1. Right down here, first part, P1 is equal to the power we get dissipated can be expressed as I square R or V square by R or VI. You have to remember these different expressions. But in series, which is constant, current is constant. So in terms of this constant parameter, you have to express. This you have to remember in series. So you have to say P is equal to I square R, as I is constant. Okay, so you have for P1 you have to take it as I square R1, I square R1. So what is this? I is what is I? 2 by 3 ampere, 2 by 3 ampere. So I square means 2 by 3 whole square into R1 is 2. So it is equal to 4 by 9 into 2. So it is 4 to 8, 8 by 9. So P1 is equal to 8 by 9 power watt. In decimals also you can express accordingly. Right? Put this, usually put the answers in a box so that it will be clear. So second, power dissipated across second resistor P2 is equal to I square R2. So it is equal to I square is what? Again 2 by 3 whole square into what is R2 is 3 ohm. So 3, so it is equal to 4 by 9 into 3. So 3 ones, 3 threes is 4 by 3 watt, or so you can also write it as 1.3333. So 1.3 watt. 1.3 watt. So depending on the requirement, if the options are given for this question, so you have to observe the options. If the options are given in fractions or decimals, and then you have to simplify. Then the third part of this is power dissipated across the third resistor is P3 is equal to I square R3 is equal to I square 2 by 3 square into R3 is 4. So it is 4 by 9 into 4, 4 fours, 16 by 9 watt, or 9 ones 9, 9 twos 18. So 1 times it goes 9 ones 9, then 7, 70. So many times it goes? Mm, yes. Ah, 9 ones 9, 7. I just I'm weak in the tables, so you can calculate 9 9 5 9 1 9 1 is 9 9 2 is 9 2 is 18. Just calculate and tell me what is this 16 by 9, guys. 16 by 9, 16 divided by 9. Yes, 1 point. You can say 777. So or 1.8, approximately 1.8 watt. So this is the power dissipated across the third. The power dissipated across the third resistor. Right, this is how you can calculate the power dissipated across each resistor in the circuit. Then the fifth point is there, right? Fifth question, sub question. What is that? Uh, the power supplied by the battery. What is the power supplied? What is the power supplied by the battery? You have to say power supplied by the battery. What is the power supplied, guys? Right? You can calculate this. Power supplied by the battery. Power power supplied by the battery because battery is having potential difference of 6 volts. So power supplied V is equal to, we can say VI or I square R or V square by R. So here battery's potential difference is given. So we can take it as V square by resistance of the circuit is given as R effective. So here by taking this we can find out what is the power supplied by the battery with the potential difference of 8 volts. So as V is 6 volts, so 6 square is 36 by R effective is 9. 9 fours, how much? You can calculate this, right? 9 fours for 36, right? 9 fours 4 watt. 4 watt of power is supplied by the battery, and this is distributed across each resistors as 8 by 9 watt and 1.3 watt and 1.8 watt, etc. Right? This is how we have to calculate. There's a problem. The server, what? Okay, I hope is going on. The live is going on. Right, guys. So this is how. Yeah. So this is how you have to just calculate what is that the different parameters in this in such cases. So go back and pause the video and write down each point and practice by on your own. These simple things are okay. How to find the resistance in series combination, how to find the current, and how to find potential differences across each resistor, and the especially the power dissipated part. You have to remember that in series combination current is constant, so try to express the power dissipated across each resistor. Try to express power dissipated across each resistor is the constant term in the combination square. Here if constant in terms of constant term, here in series current is constant, so I square r. If parallel combination if we consider, then potential will be constant, so we have to express in case of parallel combination power dissipated is nothing but v square by r. That way you have to take v square by r1, v square by r2, v square by r3, like that you have to take. So keep these points in mind. Next, another miscellaneous question I will give. So you guys can practice some similar kind of questions also. Right. Not on this question. Next question. Yeah. See, some simple questions. Let us consider one simple question here. The question is the question is when a steady current flows in a metallic conductor of a non-uniform area of cross section, which of the following quantities is constant along the conductor? Some options are given. Options are given. You see here, the question is, what is note down is when a steady current flows, when steady current or constant current, steady current flows, when a steady current flows in a metallic conductor, in a metallic conductor of non-uniform area, of not uniform area. Uniform area means area of this conductor will be constant throughout, but it is having non-uniform area. A conductor of non-uniform area, non-uniform area. Which of the following quantities is constant? Come on. Which of the following which of the following quantities, which of the following quantities remains constant? Remains constant. Remains constant. Options. First option, current, electric current. Electric current. Second option, current density, current density. Third option, electric field, electric field. Fourth option, drift speed, drift speed. Yes, you can guess which is constant. Yeah. So what you have to understand is, if you observe this pictorially, the question, there is a non-uniform wire. So uniform wire means, let us say, this wire can be treated as a uniform wire. Means area will be constant throughout the wire. It is uniform wire. This is a uniform wire. Non-uniform wire means how it looks like. Non-uniform wire means a wire of uniform area. Non-uniform wire of non-uniform area. Wire of non-uniform area. So area should not be constant. So that means, so you have to just, you can represent like this, either in this fashion, or initially having larger area, then area will be decreasing like this kind of fashion also. This will be a conductor having non-uniform area. In this, if a current I is flowing, current I is flowing, current I is flowing, the question is, you can read the question once again now. When steady current means a constant current flow. Actually, meaning of this is steady current means that itself is giving you an idea. Steady current means a fixed current. Okay, so non-variable current means constant current. When constant current flows in a metallic conductor of non-uniform area, which of the following quantities remains constant? Obviously, steady current means constant current, which is constant. Electric current will be constant. No questioning that actually. So, but you may confuse just by looking at all these points. But electric current will be constant. What about the others? Why not current density will be constant? Huh? Because why? You can just you can observe. So current density. Why current density is not constant? You can take this here. Current density J is equal to I by A. As area is non-uniform here, area is varying. Current density will be varying. It is not constant. It is not constant because area is not constant. Because area is variable. Because area is variable. So that is not correct. Then what about electric field? Why electric field is not constant? So to understand this, let us observe drift speed first. Drift speed. Drift speed. You should know this about these points also. Then only you can confidently you can select the current is constant. Okay, that's why I am explaining the other options also. Drift speed. VD. You may ask, once you know the answer, why you are discussing about other points. So you need to have an idea, then only just confidently can choose that option. That's why. So drift speed is, you can say, as I is equal to NEAVD. So VD is equal to I by NEA. When current is constant, number density is constant, charge of each carrier is constant, but area is varying. When area is varying, drift speed will be varying. So it is not constant. Is not constant. So drift speed also variable. So okay, then how can you say electric field is varying in this in such case? Current is flowing means you have to imagine that it is connected to some battery. Then only as external source or battery, then only current will flow. That's what you have to keep in mind. Okay. So if it is having potential difference V and having some length L, then it will this battery will establish some electric field. What kind of electric field it is? Variable or constant. So the simply here I can say the electric field in this case depends on not only as a E equal to dV by dr, some other parameters also depends on. So what you can understand here is mobility. Mu is equal to drift velocity by electric field, drift velocity per unit electric field. So from this, can we say electric field E is equal to drift speed by mobility? So from this, as drift speed is variable, so electric field also will be variable, it is not constant. So this is how we can conclude that these are all not constants, and hence of course electric current will be constant. Electric current will be constant. Here just actually you may ask, without knowing electric current is constant, how can you say drift velocity is because here drift velocity is I by NEA, A is variable. So we can conclude VD is variable. That's it. So as VD is variable, E also will be variable. E also will be variable. So this is how we can conceptually have to observe and have to just answer this kind of questions. This simple conceptual based question. Still, you need to have a proper idea. Then only can answer confidently, right? Okay, guys. Just I am pausing here. Just you guys can take a small break and have dinner. Then again, you can go through a few more questions. Just I may continue after few moments.